Example. A farmer needs to fence in rectangular fields containing an area of 600 square meters. If the field has a fence down the middle parallel to one side, what is the smallest amount of fence that he can use? Usually in word problem we will start with a nice drawing. The drawing not only shows the situation but also labeling, so I know what is x and what is y. So x is the width and y is the length. This means that x times y, the total area, must be 600. This is an equation. If you take a value of x, you're stuck with only one value of the y. Let's see now what do we have to minimize. The amount of fence. What is the amount of fence? Oh well, just look at the drawing. We have 3 times x and we have 2 times y. So f equals 3x plus 2y. This is a function. The first thing to do is to get rid of one of the variables. Let's get rid of the y. So I'm using the equation, and I know that y is 600 over x, and I'm going to substitute in the function. You always want to simplify everything, so after simplifying I get this function. Is this an open or closed interval? Well, it is definitely open, or if you want semi-open, okay? The values of x's cannot be negative, but they can be as large as one wants. Why? Well, let's see. The dimension only cannot be negative, but it can be a very large number. Again, do not use your logic. Use mathematics here, okay? We can have, for example, x to be really, really huge, and we are getting very long and very narrow area, but the total area can still be 600 square meters. So this is an open interval problem, so I know how to proceed now. I'm going to find critical numbers, and then I'm going to see what is the shape of the graph. So critical number, let's differentiate the function and solve for 0. Divide by 3 both sides. Now we have 2 possibilities actually for x, but we don't need to do all that because x is non-negative. So I know that the only solution here is x equals 20 meters. Now let's see the shape of the graph. So I'm going to do the first derivative, analysis on the real line, but I'm going to start only from 0 this time. Really good sample points are 10 or 30. Okay, so on one side you can take 10 and plug into the derivative and you see that the function is decreasing there. And then at 30 you will get that the derivative is positive, so the function is increasing there. So what is the shape of the graph on the interval 0 infinity? It's this. So I can definitely see that to any x's which are not 20, the value of the function is more than f of 20. It means that f of 20 is mean. What is f of 20? We are going to substitute in the function and we get 120 meters. You always like to reread the question to see if we really answer the question. In this one, we ask to find the smallest amount of the fence. Okay, we did that because we have f of 20. So we are done. Let's see in general how we are solving optimization problems. The first thing is to draw a label. Then we have to find the equation, the constraint. And then the function to optimize. Now we have to use the equation to reduce the variables in the function to be only one. We right now know only how to optimize functions which has one variable. If you have the right equation, you will always be able to do that. Now we are thinking about possible values for the variable. And we always need to find the critical numbers in the set of possible values. For example, many times because it's word problems and real-life situation, there will be a restriction also that the variable has to be non-negative. So if you get a critical number which is negative, you shouldn't care about it. Now we have to show that indeed we get absolute maximum or minimum. And we have two cases. If it's a closed interval, it's easy. We're just going to do a chart. And I recall in the chart, we are going to have all critical numbers and the endpoints A and B. If it's an open interval, we are going to do the first derivative test and show the shape of the graph. And please recall, those are word problems. So the answer has to be using units if there are units in the problem. And also, you always want to reread the problem to see that indeed you answer what was asked for you to find. Example: a manufacturer needs to produce a cylindrical closed 1 mm thick aluminum can to hold 500 cubic centimeters of liquid. Find the dimension of the can that should be manufactured to minimize the cost. Well, this is a really, real life situation here. You work in a place that manufacture some kind of packages and you really want to minimize the cost of each one because it will save a lot of money for the company. Okay, we need to start with a nice drawing. So here is a cylindrical can, and we see now that we need two dimensions, R and H. But now we need to produce that. So we need the bottom, we need the top, and we need the side. The side actually is a rectangle. If you take the rectangle around the bottom and the top, that's how you get the side of a cylindrical can. Okay, so let's see now. The bottom and the top is what? Each one of those areas is pi r to the power of 2. What is the area of this rectangle? Well, one side is the height and the other side is the circumference of the bottom or the top, which is 2 pi r. So the total area of this part is 2 pi r times h. Let's find the equation. We have a restriction for the volume. So the volume of the cylinder has to be 500. The volume of a cylinder is the base, which is pi r to the power of 2, times the height, which is h. So this is the equation. What is the function? The function is the sum of all those areas that we have above in the picture. So we have 2 times pi r to the power of 2 for the bottom and the top, and then we have the side, which is 2 pi r h. I have two variables. I definitely need to reduce one of the variable. Which one should I reduce? The r or the h? Definitely the r is not going to be reduced because we have r to the power of 2 and we have r and it's really complicated. So we are just going to get rid of this h. We are going to use the equation. What is h? H is 500 over pi r to the power of 2. So let's substitute in the function. We always would like to simplify because I remember the next step is critical. So really simplify this as possible. And we get that the function to be minimized is 2 pi r to the power of 2 plus 1000 over r. Let's now find possible value for the variable r. Well, we just have to observe the equation. Let's say that r is 2 billion. Can I solve this to h and h is non-negative? Yes, I can. It means that r can be anything, positive obviously, or 0. So r is between 0 and infinity. Let's find out the critical number or numbers. Well, the derivative is this. Let's solve for 0. Okay, so you multiply by r to the power of 2 both sides, and you get that. Yeah, it looks pretty nasty, but you know what? This is the r. So r is 10 over cubic root of 4 pi centimeters. Now I need to check that this is really absolute minimum. So because it's an open interval problem, I will have to use the first derivative test to find the shape of the graph. So here it is. The function is decreasing, increasing, and this is the shape of the graph. So the shape of the graph suggests that indeed, for all other values which are not this one, we get that the function is more. And please note, I'm only checking from 0 to infinity. So again, I get that this is absolute minimum. So now we answer the question. Well, they asked me about dimensions. And what I got here is only one dimension, which is r. So I still need to find h, using the equation, obviously. So if this is r, I'm going to use the equation again, and the connection between h and r to find h. So let's substitute this for r, and we get that.